Hello everyone, welcome to Gatewala. Welcome to Compiler Design Subjects. In our previous classes, we were discussing some topics of parsing. Parsing is one of the second phase of the compiler. So second program which is doing syntax analysis, parsing also called as syntax analysis. So welcome you all to the next phase. In today's class, we are going to discuss about the next program, that is a third program in compiler. Before going to start this, so let us see what we were discussing in the previous classes. Look at here, in our previous classes, we were discussing about some of the phases of this compiler. So lexical analysis, this is already over. In this, so what is the input to the lexical analyzer? High level language, the output is tokens. And in the session, we have discussed how the tokens are produced, how we can generate tokens from the given high level language. Next one, parser, syntax analyzer. Syntax analyzer are also called as parser. In our previous classes, we were discussing how to design this. So in our last class, we have seen LR, SLR table construction. We have designed some of the tables, right? Attach these tables to the shift reduce parser. Then shift reduce parser is doing parsing. That is called as LR parsing. Okay. So that LR parser, the total table plus shift reduce parsing together, if you program, that is our parser. That is by using bottom up parser. Similarly, we have top down parser called as LL1 parser. So top down parser in which LL1 is important, top down parser in which LR is important, those things we discussed. So by using those, we can design syntax analyzer or parser. So what is the output of these programs? So what is the output of this program, syntax analyzer or parser? It takes tokens as input. Along with tokens, it will take the context free grammars as input and produces parse tree as output. For valid syntax, if your token sequence is valid, it will produce parse tree as output. If the token sequence is not a valid thing, it returns syntax error as output. So here it is lexical error. So lexical error, syntax error, these outputs it will produce. Right. So in today's session, there are three types of errors detected by compilers. So welcome you all. Good evening, welcome. Hello Rohan, how are you? See here, yes, in a short way, we are discussing about compiler design in a small module course, okay, like a crash course kind of thing, okay, for get point of view, especially all these things are for get point of view. Get 2025 point of view, okay, right. So we in this, see here, from the syntax analysis part, from this part, so we have how to design parsers. The most important things are designing of parsers. The most important thing is parser designing. In the parser designing, there are two types of parsers. So where we have to focus is from top down parser. Top down parser, we'll get questions from LL1, parsing. From bottom up parser, we'll get questions from, questions from, I'll give practice questions as well, okay. We'll get questions from LR parsing. Most important thing, LR parsing. That too in table constructions. Mainly you have to focus on table construction. So in our last classes, in our previous classes, we were discussing about how to construct table. If it is a top-down parser, we have seen the L1 table construction. From there, we can get questions. So many questions are there, including in the GATE 2024 also. We have a question in that. So, bottom-up parser, LR parsing is the most important thing. Okay, and these things we discussed in previous classes. Today's session, we were discussing about semantic analysis. See, there are three types of errors detected by compilers: lexical, syntax, semantic errors. Lexical errors identified by first program, lexical analyzer. Syntax errors identified by second program, parser or syntax analyzer. Third type of errors, because syntax analysis don't have the capability to detect some more errors called as semantic errors. That's why in order to identify your semantic errors, we need to design a phase called as semantic analysis phase. So these are the three type of errors. Here generally these are the three type of errors normally detected by compiler. Whenever you program anything, you write a program, C program, C++, Java, the moment you compile, the compiler, the first task of the compiler is, it is detecting errors present in the program. Generally these are the errors normally compilers can able to detect. So in a programming point of view, say compile time errors, but in compiler, those compile time errors also subdivided into three categories. Lexical errors, some of the basic errors which are invalid tokens. Syntax errors, which are the errors not matching with our parser detecting errors. So we are doing parsing. So these are called as grammatical errors, normal structure of the statement mistake. I think whenever we are studying any program, for loop syntax, expression syntax, if any mistake in the syntax, if you missed anything from the syntax, if you give additional thing than given syntax, all these syntax errors will be detected by here. Semantic errors are something called as meaningless statements. Semantic errors are in which statements are syntactically okay, but meanings will not be there. So those type of errors will be identified here. Semantic error, semantic and all. In today's class, we are discussing about how to design this program, semantic. So semantic analyzer. Look at this. To design lexical analyzer, so I told you in the initial class, here for GATE point of view, compiler design, we have to learn theoretical point of view. What kind of techniques, what kind of theoretical concepts involved in designing of every program. See here, writing program is not required. Nobody will ask you in GATE papers how to write a program to construct lexical analyzer. We don't want that. What we want, what are the theoretical concepts inside? Okay. To design lexical analyzer, first program, we want the concept of finite automata. Finite automata in order to recognize tokens. Some regular expressions, finite automata, that one. So token detection will be done with the help of finite automata concept. The finite automata concept, you should have an idea. That is part of theory of computation concepts. That's why we are not discussing here. Okay. But the knowledge, theoretical knowledge required to design this one is definitely finite automata. To design the second program, syntax analyzer, the theoretical knowledge or the concepts which are used is context-free grammars, parsing algorithms. So in this course, we discussed about context-free grammars. What is a context-free grammar? What is ambiguous grammar? What is unambiguous grammar? That is required. Next, parsing algorithms. The two type of parsing algorithms. So top-down parsing algorithm, bottom-up parsing algorithm. So by using these grammars, by taking these grammars and tokens, we will design a parser. The parser can be a top-down parser, LL1 parser, or bottom-up parser. So these are the theoretical concepts involved in this. Like this, to design semantic analyzer. What is the theoretical concept involved? Now we are going to learn about one concept called as syntax directed translation. So today our discussion is completely on this only. This syntax directed translation is a concept which is used to design coming two phases of compiler, that is semantic analyzer as well as intermediate code generation. So semantic analysis and intermediate code generation, these two, for which the theoretical concept involved inside is syntax directed translation. So in today's class, we are going to see what is this syntax directed translation, how it is different from previous concepts, what is this theoretical concept. Well, this is one of the very important one. There are so many questions in gate papers, especially in compiler design. Whenever they want to give any tricky questions or somewhat complex level questions, the examiner will always focus on this area, this chapter, syntax directed translation. So in the gate paper also, this year you see the gate syllabus, in the syllabus in compiler design, this name is specially mentioned, syntax directed translation in compiler subject. So let us, in today's class, let us go and observe what is this syntax directed translation. Syntax directed translation is the concept used to design, this program of semantic analysis. So in the semantic analysis, whatever the task you want to perform, like detection of semantic errors, construction of symbol tables, whatever the thing you are doing, that is with the help of, with the concept of syntax directed translation. What is this? Here, every context-free grammar production is associated with set of semantic rules. Set of semantic rules. So I will show you some of the examples of syntax directed translations. Look at this. This is one SDT. This is one of the syntax directed translation. In short forms, generally we will call it as a SDTs, but here syntax, generally the name of this one is syntax directed translation. This is one of the syntax directed translation. Now, what is the difference here? Let me explain the difference of this one. Syntax directed translation is nothing but context-free grammar productions. We are having context-free grammar productions which are designed at the time of parser. Same context-free grammar productions which are designed at the time of parsers, for which some associate rules are there, because semantics is something beyond syntax, something more than syntax. Okay, so here we have grammar productions, plus for every grammar production we have a rule. We have a grammar production. This is grammar production. We know the construction of context-free grammars by using NTPS notation. How to construct context-free grammars, we already practiced at the design of parser. So what we need to practice here is, what are these semantic rules? So here our focus should be on all these things are called as semantic rules. So this grammar plus semantic rule. So grammar production plus semantic rule. So this total structure is called as a SDT. So here SDT is nothing but, syntax directed translation is nothing but simply a context-free grammar production having semantic rules plus semantic rule. These structures are clearly available here. So the design of semantic analysis, is the designing of these type of structures. So CFG plus rule. This plus is not required, for your understanding I am giving this. So having this is called as SDT. That's why syntax directed translation is context-free grammar production having semantic rules. So these structures clearly visible here. So what you have to practice for gate point of view from this part is, if these type of things are giving, how to analyze this and how to construct this. That is what our aim. So in today's class, our discussion is on that. So, and we'll see some more. Look at this. This is one more SDT. grammar production, its rule. The rule can be anything. So this is grammar production plus rule, grammar production plus rule, grammar production plus rule. Like this, a context-free grammar production having semantic rules. Not only one, the semantic rule can be set of semantic rules. Sometimes may not be there, sometimes more than one can be there. All these are allowed here. So context-free grammar production associated with set of semantic rules. This structure is called as SDT, syntax directed translation. Okay. So syntax directed translations in which rules can be. There are some more SDTs you can see here. This is one more SDT. Look at this. The rule is there in the middle part. This is also allowed. So sometimes we can take semantic rules even in the middle of the productions. Look at this. The rule is there in the middle. Rule can be there anywhere. It can be there in the middle. It can be there in the starting. It can be there in the ending. It can be in anywhere. Okay. Look at this. The rule is there in the middle. So like this also allowed in SDTs. Okay. Now what we have to practice here is, if these type of SDTs are given, how to evaluate. So this is one of the question. Asked in 1 year GATE. This is the question directly from GATE paper. So how we'll get the question is, what is the output for the expression 2-3 plus 4? We can get like this, or what is the value of E dot value of the root? E dot value for root. So any value of this, E dot value is what? Or what output it will print for the this one, like this. The questions will be, so he will give some input. The SDT will be there. So this is some input for the SDT. This is the input. It is expression because this SDT is doing evaluation of expression. So what is the value of for the expression? I'm changing this question to what is the, we can take like this, it will be better. What is E dot value? What it is dot value for the expression 2-3 for the expression 2-3 for like this. So he has given SDT. Already there are some grammar productions, rules are there. What we need to do is, whenever SDTs are given, the first thing is, if you want to evaluate values from SDTs, first thing for the given input, construct a parse tree. First thing, construct parse tree. This is for all. Whenever SDTs are there, for evaluation of SDTs, syntax directed translations, what you need to do is construct the parse tree. Parse tree construction is the first step. Parse tree construction. So for this input, we need to construct the parse tree. So the parse tree will be, look at this. This is the parse tree for this. So our input is 2-3. Let us see here. This is 2-3 ampersand 5-6 5-6 ampersand 4. Read all leaf notes. So this is hash here. So this is ampersand. So this is the hash here. This is the ampersand. So 2 hash 3 ampersand 5 hash 6 ampersand 4. So like this you have to construct the parse tree for the given input. Whenever input is given, for this no need to see here. The tree construction, parse tree, semantic rules don't have any involvement in this construction of parse tree. To construct parse tree construction is just a grammar concept. So based on this grammar production, forget about this one. Initially, by using this grammar production for this input, you construct a parse tree. Parse tree. Okay. Then now compute what we want. What is e dot val? The e dot value of the root. E dot value for the root value. Here because we have this one also, we need to compute this one, root value. So in the parse tree, we need to compute this. How to compute? So however the rules are there, see here, very simple. When the SDT evaluation is like this, whenever we are using any production, any grammar production, its associated rule we have to evaluate. That is the thing. So assume we are using f2 num, this production. What is the rule? The number dot value is copied to f dot value. Number value copied to f dot value. So first what we have to do, convert this this value is called as attribute. So for every non-terminal, take this e dot value like this, because we need to compute now. Right. So now I am using this production f2 num. Assume using this production. What is the rule associated here? The number value whatever is there, copy to f dot value. So what is f dot value now? Tell me here in this. Can you guess what is the f dot value according to our semantic rule? Whenever we are using this production, this rule is executed. This rule is just assignment. So whatever the number value will be there here, number value is nothing but 2. So that is copied to f dot value. So what is the f dot value as per the given thing? The rule is saying whatever the number value is there, assigned to this. That's why here 2, whenever we are using this production, here it is 2. The value of this number is 2. That's why the value 2 is assigned to this place. Here 2 is assigned. F dot value is becomes 2 now. 2. Next, assume parser is using, otherwise we are using this production. T2F. Whenever using T2F production, what is the semantic rule associated here? Whenever you are using this production, what is the semantic rule? This is the production. Okay. What is the rule? Whatever the f value will be there, f value will be assigned to t value. F value will be assigned to t value. So same rule. Whenever here the difference between parsing and semantic analysis is, in the parsing only grammar productions are used for the checking of syntax and everything. Here whenever grammar production is used, its rule also will be executed. If we are using any production, its rule also we need to execute. Here all the rules are just assignment things, values copying. That's why whenever we are using this, f value will be copied to t value. So what is that? So here also we'll get value as 2. Next we are using e to t. So e to t, whenever we are using t value whatever is there, copy to this. So here t value, this is becoming a t value whatever is there, that is copied to here 2. So this is copied here, this is copied here, this is copied here. Is it clear? I think. Any confusion here? Just whatever the semantic rules are there. So just whenever you are using grammar production in the parse tree is the main thing here. There is no any new concept. First you construct a parse tree. In the parse tree, in the parse tree. However, the semantic rules are there. You just pass the semantic rules. The semantic rules are nothing but simply value calculation things. That's why it is easy. Next, same thing. Whenever you are using this production, the f value is nothing but, what is the rule? So same thing. Whenever we are using this grammar production, its rule, number value will be assigned to f value. So what is the number value? 3. That will be assigned here. 3. Then we are using this. So f value assigned to here, that is known thing. Whenever we are using f to num, this value 5 will be assigned here. Very good. Next we are using the production as t to t ampersand f. Look at here, where is that production? T to t ampersand f. Then this rule has to be executed. What is this rule is doing? See, in order to differentiate these two t same, I am assuming this is t1. So right side t, just giving the name as t1 assume. Then t1 value, f value, add these two, assign to here. This is the rule. So plus, add these two plus. So here addition we don't know, just by looking about this. Whenever we are using this production, we don't know its rule. Plus addition we have to perform, multiplication we have to perform, that is not known. So what need to be done here is, see the rule, semantic rule. What is the semantic rule is saying? Semantic rule is saying that this value, its value and its value, add these two. Add these two. So if we add these two, we'll get the value here as 8. 8. Okay, right. Similarly, whenever we are using this production, e to e hash t, see here, e to e hash t, this is assume e1, right side e1. Then whenever hash symbol is there, this production is there, e value, t value, multiplication. If it is a multiplication, what we will get here? This e dot value is nothing but multiplication of these two. We'll get it as 16. Okay, right. Same here. The value of this is 6. Here it is, t value, f value is copied. Here also 6. Here it is 4. And whenever we are using t to t ampersand f, what is the rule here? t1 value, f value, add these two. This one add. So this t value is nothing but 10. Now what is the final e value? Compute. Whenever we are using this production, e to e hash t, what is the rule is saying? E1 value multiplied with t value assigned to this. So what is our final e dot value? What will be the answer here? So what is the rule is saying? Whenever e to e hash t, whenever we are using this, so the rule is simply saying multiplication of these two. Multiplication of this. So multiplication of this one, that is nothing but 160. So this is the question, sometime asked in a gate paper. So for that it is 160. 160 is the e dot value. Like this, there are so many questions asked in the SDT. SDT is nothing. SDT is nothing. So for our grammar productions, rules are there. So already rules are there. There is no, if you want to design these rules, that is also easy, but there you need to spend more time. Designing of these rules, there you need to spend. That means construction of SDT takes little bit of time, but already SDT is given, rules are given, then it will not take much time, and that too it is very easy task. Okay. Any doubt in this? So here main thing is, first construct parse tree. After this, whatever the tree structure visible, no, this is called as annotated parse tree. This is called as annotated parse tree. So this is the output of the semantic analyzer. So if we observe semantic analysis, the input to the semantic analysis is parse tree. The output is annotated parse tree, which is a result of SDT. So the input outputs of semantic analyzer will be input is parse tree, output is annotated parse tree. Okay, like this. So rules are given already. Whenever the rules are given, the way of execution of semantic rules is, so SDT syntax directed translation is nothing but our context free grammar. In that, for the given productions, semantic rules are there, associated semantic rules are there, that's all. There is nothing new thing here. Okay, please identify if you are feeling anywhere any confusion, any difficult. I'll give 1 minute time. You can ask me doubts in the chat box. If anybody having doubt, please ask me. Because this is the first one, no, that's why I'm asking you. If you are facing anywhere difficulty, you can ask me doubts. Otherwise, we can go with some other SDTs. Any doubts? Okay, then we'll go with some other. The SDTs are having different natures. Look at this. This is one more SDT. What output this SDT? See here, this is one more syntax directed translation, which is given. Sometimes the previous one is for evaluation of expressions. This SDTs are doing different tasks here. Syntax directed translations are doing different varieties of tasks. Okay, some SDTs are doing for evaluation of expressions. These SDTs are there for printing of numbers. So the question what he is asking is, the SDTs are different. That SDTs will be used for construction of syntax trees. There are so many applications of SDTs. So for printing of any numbers, for construction of syntax trees, for detection of semantic errors, like this we have many number of tasks we can do with the SDTs. Here this SDT is there in order to print something. So what output this SDT prints for the input? This is the input. What output this SDT will print? If this SDT carried out with bottom up parser, here BOP is nothing but bottom up parser. What the question here is, so SDTs, see here, SDTs how they will be executed. SDTs are after designing the SDTs, after designing syntax directed translations, SDTs are again carried out with parsers. So parser is the main thing here. So whether it may be top down parser or bottom up parser, finally these SDTs are running with parser. Sometimes with top down parser, sometimes with bottom up parser. If these SDTs are running with a parser, what is the output it will print? That is what the question here. It's very simple one. So generally where you will confuse is, here previously expressions are there, here expressions are not there. Whatever it may be. That too, the beauty of this question is, this is also one time asked in GATE. The beauty of this question is, he is asking this, you run this SDT with a parser, that too bottom up parser. Okay, then what output it will print? It's very good question. So SDTs, see here, SDT is running with bottom up parser. Then how the parser is using productions, accordingly its rules also will execute. For that we have to perform bottom up parsing on the given input. Okay, first let us perform a bottom up parsing. Okay, that is known for you. I'm not explaining much on the bottom-up parsing. Bottom-up parsing is completely on handle detection. So first this will be reduced to this. This is the handle. So this is reduced to this. Next this one replaced by W. Next this one XXW will be replaced by S. Next this is the handle, that is replaced by W. Then this is the handle replaced to S. Right. So now how these rules will be executed? It's very simple here. If the SDT is carried out, with a bottom-up parser, whenever your parser is performing reduce action, handle is detected, reduce time, we have to use production. Look at this. This is the handle detected. Whenever a handle is detected, reduce to S, right? At this time, that means we are using this production. Its rule also will be executed. Whenever you are using production, its rule will be executed. That is the bottom-up parser. So first, what production we are using? S to Y. So its rule, that is 2 will be printed. I am showing the output here. This is the way bottom-up parsing is performed, handle detection. That is known already. We have discussed this in a bottom-up parser class. So bottom-up parser performs parsing based on handle detection concept. So SDT is not a separate concept. It is also along with parser only. That's why you should have a good knowledge about parsing. Hence we spend a lot of time on the parsing here also. So better to have a very good knowledge on parsing. Right. Then what is the next thing? SZ is replaced by W. This is the, so this production is used. Whenever this production is used, its rule also. So the SDT concept is very simple. Whenever you are using any production, if you touch any production, whatever the rule is there, semantic rule, that we have to execute. So whether it may be parser or normal in parse trees or anywhere, if you are using one grammar production means its rule also you need to execute. Very good. So next, so 3 will be printed, this one. So in the third step, what happens? So SZ is replaced by W. Next, what is the handle here in the third step? XXW, first one. So this is replaced by S. This is what happening. So whenever this production is used, its rule 1 will be printed. 1 will be printed. Okay, right. Next one, what is the next? The fourth step, what is the handle? SZ replaced by W. 3 rule is there. 3 will be printed. Next, what is the handle? This one replaced by S. So first one, this is the production I am using. When I'm using any production, its rule. So 1 2 3 1 3 1. So the answer for this question is, what output this SDT prints for the input is 23131. 23131. That's why. So the answer for this is, it prints, if this SDT is carried out bottom-up parser, for this input, the output it will print is 23131. This is the output it will print. So like this, whenever SDT is of this type getting, then this is the way you have to perform this, right? Though we have a similar question here. This is also asked one time in the GATE paper. Here is the SDT. Here is the SDT. If this SDT is carried out with bottom-up parser, what output it prints for the input? AAB. So same thing. So input is AAB. We have to do the AAB. Handle detection properly. If you Can you provide anyone answer for this? What answer we'll get? First, you have to perform bottom up parsing perfectly. Then only you will get the starting symbol. Okay, you can do that. Handle detections you do properly. So first one is this A is replaced to S. Then this is our handle. This total thing is replaced by A. Then this total thing is replaced to S. This is the perfect way of performing bottom up parsing. Some students will do this A first. This they will reduce to S. Then you don't get the starting symbol. Whichever the path is giving starting symbol, those are our sequence of handles. If you reduce the first one, that is not handle. So here that is a bottom up parsing concept anyhow. Right. So in the first step, I detected a handle and replaced to S. This is a handle replaced to S. So A is replaced to S, in which what is the rule here? Associated rule 2. So 2 is printed first. Then SB is the handle that is replaced to A. SB replaced to A. Then 3 will be printed. Then AA replaced to S. 1 will be printed. 1 will be printed. So that the output for this will be 231. Same thing. If this SDT is carried out with bottom up parser, however the parsing is happening, in the parsing time, parser which production is using for its parsing, for handle detection or for any concept, whenever it is using any production, its associated rule will be executed. Okay, right. If these SDTs are like this, okay. Sometimes our SDTs, we have some more SDTs of this kind. Look at this SDT. What output this translation scheme, SDTs also can be called as translation scheme, will print for the input 2 star 3 plus 4. This is our input. The question is, what is the problem here? This SDT, look at this, rules are there in the middle. There are so many SDTs here in which rules can be there in the middle also. You can see some SDTs here. Look at this. The rule is there in the middle. Rule is there in the middle. If rule is there in the middle, then how it will be executing? If this type of SDTs, whenever you are getting, this is also simple concept. Whenever rules are there in the middle or in the starting rightmost end, this method, this whatever I am explaining now, it will work for everywhere. So if you want to execute SDTs in a proper way, what you have to do is, whatever the rules are there, treat them as a grammar symbols. So first, for this input, we have to construct the parse tree, right? We have to construct the parse tree. At the time of constructing parse tree, you can use this for any SDT. At the time of constructing parse tree, assuming these rules also as grammar symbols, provide edge in the parse tree. So look at this. So for this input, I have to construct parse tree. So first look at this, S2 ER, E2 F, F2. See, F2 what is there? F2 ID print ID dot val. So this is the rule, no? For this also, for this rule also, print ID dot val. We need to provide edge. Look at this. This ID is grammar symbol. And now I am assuming this rule also, semantic rule also, as a grammar symbol at the edge. Right. Next, R. Look at the R production. R gives star E rule R. So whenever you are constructing tree structure, for the rule also, star E, look at this. Star E, that rule, then R. Star E, print star R. See here, star E, print star R. Next, E to F plus E for this input. 2 plus 2 star 3 plus 4. Here it is 2. Next, E to F plus E. What is E here? F plus E, print plus. This is also grammar symbol, our grammar symbol. So by assuming that F plus E, print plus. By assuming grammar symbol, I am providing H. Then F to ID, and then here print ID dot val rule. Then here E to F, F to ID, print ID dot val. Print ID dot val. Okay, like this. Now this is 3, this is 4. Read all the leaf nodes. 2 star, like this, leaf nodes 2 star 3 plus 4. That's all. Remaining epsilons, nothing. So 2 star 3 plus 4. First you construct the parse tree like this. Whenever you are constructing parse tree, for the semantic rules, then you don't have confusion. If you provide edges for semantic rules, we will not get any confusion. Then what you have to perform is perform depth first search, DFS, depth first search, left to right. Execute all this, left to right, traversal, perform on this. Travel this tree in depth first search, left to right manner. Then however the rules are executed, in that way our semantic rules also will be executed. Okay, so let us perform DFS left to right. I think everybody knows about DFS, so I'm start from here. This one, again it is having any siblings, go with that. So then see here, first 2 will be printed. This, it is touching the rule, ID value what is there, 2. Then once all siblings are completed, go back, then go back. If you don't know DFS, just in data structure we will have so many DFS algorithms, just go through them. I'm performing DFS on this. So this whatever by the SDT, in total SDT concept, you can use this. So SDT, whenever SDT is there, construct the tree structure by including rules, perform DFS left to right. You will get the value for every SDT. Then see here, whenever you are touching the rule, print it. Print ID dot val, value of this 3. Then plus print ID dot val. So what is the value here? 4. 4 will be printed. Then come back here, plus semantic rule. Whenever you are executing, whenever you touch the rule, execute that. So print plus will be printed. So all these things are over, then come back. All its siblings are over, then next star. Now star will be printed. That's all. Okay, this is the way. So whenever any, so very simple, whenever you have any SDTs of this kind, in which rules are there anywhere, rules are there in the middle, starting, anywhere, if you are feeling difficulty, very simple, construct the parse tree first. Construct the parse tree. In the parse tree, you perform a traversal, depth first search traversal from left to right manner. So this is the maximum chance. So many questions are there in the gate paper on this kind. So whenever these type of questions are there, the way of solving this is like this only. It's very easy. Okay. So these are called as SDTs. We'll say whenever these rules are there like this, even in the middle of the grammar productions, those things called as translation schemes. Translation scheme also SDT, a special name is given for such type of things called as translation scheme. In the translation scheme, rules can be there anywhere in the grammar, in the middle, in the starting, in the right, anywhere it can present. If translation schemes or anything, any SDTs are given, this is the best approach. So first construct the parse tree and traverse them from left to right. So in SDTs, these are the maximum asked possibilities. So if you want, some students are asking for homework, you can take this question as homework. This is also one of the gate question. This is SDT. In this also rule is there in the middle. So what output this translation scheme will print for the input, okay? So here instead of this, what output this translation scheme will print? What is translation scheme? SDT only will print for the input. This is the input here. So this input. Nine plus 5 plus 2, okay? Right. So these are maximum possibilities from this concept SDT. You can take this question as homework. Try yourself. Try this question. This is a gate question. If you want answer, you will get in the gate paper. Okay. Same concept. If rule is there in the middle, just what you have to do. So attach them in the rules, also attach them in the parse trees, and then okay. Right. So this is about SDT, students. SDT, syntax directed translation, is nothing but context free grammar prediction. That is, we have practiced a lot. Context free grammar prediction for which rules are there. So if it is an evaluation of how these rules will be executed, very simple. You write all the rules, along with you write the rules. Whenever your rules are there in the SDTs, most of the times, 90% of the times, evaluation of SDTs questions only will get, most of the times. If designing is there, then that is different issue. We can design based on a given concept. But evaluation wise, whatever the rule is attached to the grammar production, for that also you construct a parse tree. Provide edge in the parse tree for the rule. Okay. Like this, for our given input, you construct the whole parse tree and traverse that parse tree depth first search, left to right manner. And however, whenever any semantic rule is coming, execute them. If you execute this depth first search, left to right, this rule, this strategy will work for every SDT. So you evaluate all the semantic rules, they will be executed in a proper way. Okay, then you don't get any confusion. Okay, so that's all about syntax directed translation concept. So by using these techniques, these syntax directed translations, whole semantic analysis phase will be decided. So to design semantic analysis, this is the concept involved inside semantic analysis. Okay, right. So have a good knowledge about this concept, syntax directed translation, because for our GATE syllabus, total designing of development of semantic analysis is not there. So the concept is given as syntax directed translation. That's why if we have a good knowledge about syntax directed translation, that is enough for GATE examination point of view. Okay. Okay, students, that's all about today's topic, SDT. Okay. Thank you all. Bye bye. See you in the next class.